on with the bulk of the lab, and we're going to go to the calculations now. You can see the sample calculations of the person who did 7-3 in the book and what they wrote down for the masses for what they got when they did the experiment, and kind of follow along that process. But I'm going to go ahead and do it here on the whiteboard so that you can see the amounts we got and the calculations that we will do together. So I took those numbers from those note cards that I did earlier, and I typed them up nicely so you have them all in front of you. Please make sure all of this information is in your lab report. So the first measurement we took was the mass of the beaker, vinegar, and watch glass, and that's there. We took the mass of the beaker, vinegar, watch glass, and tablet before the reaction, and that's the second number. Lastly, I took the mass of the beaker, the vinegar, the watch glass, and the tablet after the reaction was complete and all the fizzing stopped, and I put the mass there in that third line. Now, it wanted us to find the mass of the tablet before the reaction, so I took the total weight of everything in line 2, the beaker, vinegar, glass, and tablet before the reaction, and took it away from the beaker, vinegar, and watch glass without the tablet. That difference gives me the mass of the tablet, which was 3.26 grams. Then I went ahead and I wanted to find out what the mass of the carbon dioxide was that escaped in the reaction. So this was that initial mass that was the total of the beaker, vinegar, watch glass, and tablet that before we dissolved it, minus the final measurement in the third line, the mass of the beaker, vinegar, watch glass, and tablet after the reaction and all fizzing stopped. So when I take those two numbers and take the difference, I got 0.76 grams of carbon. That was the carbon dioxide mass right here. And I was putting that stuff in like bold and underlining it so you can see it nice and easy. Okay, so that's cool. But how is that going to help me find the amount of sodium bicarbonate in the Alka-Seltzer tablet? So what we're going to do next is we're going to convert, because we can't just take the amount in the tablet before the reaction and try to calculate how much sodium bicarbonate was in it, because we know that the loss of the carbon dioxide was measurable, okay, because we were able to measure that. We can now work backwards and convert the grams of carbon dioxide mass to moles of carbon dioxide mass. And then what we're going to do is we're going to compare and find the ratio of the carbon dioxide moles to the sodium bicarbonate moles. And then we should be able to calculate how much of the moles of the tablet we have, and then from there we can figure out our percentage of how much sodium bicarbonate was in there. So the next thing we're going to do after we have those numbers and we've calculated the tablet mass and the carbon dioxide mass is now I'm going to figure out the molar mass of carbon dioxide so I can convert my carbon dioxide mass from grams into moles. So I looked at my periodic table and I wrote out what that molar mass would look like. I had one carbon dioxide atom at 12.01 AMU, and I add that to two 16.00 oxygen atoms AMU, and I get a total of 44.01 AMU of carbon dioxide. Now I know that when I take that AMU and I convert it and just say that it's grams, that's going to be 1 mole of carbon dioxide. And now I'm ready to do that calculation to essentially figure out how much carbon dioxide moles I have. But before I can really even go any further than that right now, I also am going to need to know, actually, yeah, we'll go ahead and we'll solve that first, and then we'll go to the next part. So I'll show you what that is next. Okay, so what I'll do next is I'm going to take this amount of grams. So I'm going to take this. And I'm actually going to slide over my table a little bit so that we can have that written over here, okay? So yeah, all right. So we're gonna take the grams of carbon dioxide and we're going to go ahead and open up our lovely dimensional analysis here. And we're going to convert that to moles of carbon dioxide. And I said that 44.01 grams is equal to 1 mole of carbon dioxide. I can now cross cancel my units. And the answer that I get is going to be, go ahead and do the math real quick so I can give you the raw answer there, which is important to have so we can talk about sig figs. And the answer I'm getting here is going to be 0.0172688, blah, blah, blah. Okay. Now this is just your basic answer here, but we need to look and see what our sig figs are going to limit us to. Okay. And I can see that my answer of 0.76 is going to limit me to 2 sig figs because that is where I was limited to from my 2 numbers doing multiplication and division. So I am going to be limited to 2 sig figs. Remember that we do not count numbers to the left of a number unless the zeros are in between another non-zero. But technically I could move that decimal point over and I wouldn't have any worry about where these zeros went. So these are technically my 2 sig figs I will get to keep, which means my final answer is going to be 0.17 moles of CO2. Okay, so now I've got my calculation of my moles of CO2. And I am going to take that number. I'm going to just take my hand and my little hand gripper and pull this back over like this. So now that I understand that I have 0.017 moles of CO2, which I'll go ahead and write over here. So 0.017 moles of CO2. So that's what this is equal to, okay, in moles. And now I'm going to try to figure out how many moles of sodium bicarbonate that is. And I know I can do that because I'm going to look at the coefficient in front of each one of these molecules in the chemical equation. And I know I can do a 1 to 2 or a 1 to 3 or whatever that coefficient is in front of that entire molecule. And I know that these are exact conversions. Okay. So how many technically sodium bicarbonates do I have? I have 1. I have 1 hydrogen, I have 1 oxygen, and I have 1 carbon dioxide. But all I want to know about is sodium bicarbonate right here and carbon dioxide right here. So that looks like I have a 1-to-1 ratio. If I really want to look, my molar ratio is 1 mole of carbon dioxide to 1 mole of sodium bicarbonate. Now that I understand that, because this, by the way, this chemical equation they want you to use is on page 216, and it does reference you to that. So you can use your book to view that. That also should be in your lab report, okay? So we have a 1-to-1 ratio, which means if we have 0.017 moles of carbon dioxide, that means we also have 0.017 moles of sodium bicarbonate, right? And I'll show you the math for that real quick, just so you understand what I'm saying, okay? So if I have a 1-to-1 mole ratio and I want to go from moles of carbon dioxide to moles of sodium bicarb, I'm going to open my dimensional analysis and put it over 1. And then I'm going to put my conversion factor. And remember, we are putting our conversion, which we consider exact. The coefficients are considered exact. So this doesn't get counted in my sig fig numbers, okay? I would cancel out my moles of carbon dioxide and I'd be left with moles of sodium bicarbonate. And if I do 0.017 times 1 divided by 1, I'm left with the same thing. Again, getting to keep 2 sig figs here because I had 2 sig figs here, and these don't count, okay? So this is how many moles of sodium bicarbonate I started with in here. And now I've got to figure out how many grams that is because I wanted to know what my percent composition was, but we don't really give a percent composition in moles when we're giving amounts of things in the real world, right? We only use moles when we're mathematically calculating what we're dealing with. So again, we're going to have to convert these moles of sodium bicarbonate back to grams of sodium bicarbonate, okay? I'm going to go ahead and just stretch this bar out here so that you can see what I'm doing now. So what I want to do now is I need to find out the molar mass of sodium bicarbonate. And I do that by looking at my periodic table yet again. I'm going to look at my different atoms and how many of each atom I have, find out those AMUs, add them up, and that total AMU number is going to be the equivalent to grams that equal 1 mole of sodium bicarbonate. So we're going to go ahead and type those in. Excuse me. Sodium is 22.99 AMU. And then we have hydrogen, which is just one of them, 1.01 AMU. And then we have 1 carbon, which is 12.01 AMU. And then we have 3 oxygens. So I always put those in parentheses to kind of put them by themselves to let us know that we are doing that as the calculation. And remember, we are adding, even though I've got that multiplication sign there, we understand that we're actually adding 16 plus 16 plus 16 plus 12.01 plus 1.01 plus 22.99. And the reason we do that is so that we have that sig fig limitation. We know where it's at, and we know that we can stay to the hundredths place. We end up with 84.01 AMU. And this means that 84.01 grams of sodium bicarbonate is actually 1 mole of sodium bicarbonate, okay? All right, so now that we know my molar conversion to go from moles to grams or grams to moles with sodium bicarbonate, I can now do my final math to find out how many grams of sodium bicarbonate 0.017 moles is. All right, so I'm going to go ahead and start with my amount of moles of sodium bicarbonate. And I'm going to go ahead and put that through that conversion analysis or dimensional analysis. There's my lovely conversion factor there that I just showed right here. So we know that's supposed to say G. That is a terribly written G. There we go. So 84.01 grams of sodium bicarbonate is equal to 1 mole. Well, now I have my mole to mole units that I know I can cancel to be left with grams of sodium bicarbonate. Terrible writing. I don't know what has been going on with my writing lately. All right. Now, this answer that I'm going to write here, I'm going to actually just put the raw answer for it. I am not going to put the beautiful clear sig fig, but I am going to go ahead and do 0.017 times 84.01. And I'm going to get, that's just the regular answer, 1.42817 grams of sodium bicarbonate. I know that's not my final answer though, because I have 2 sig figs here and I have 4 sig figs here, which means I can only keep 2 sig figs in my answer, which is going to be this 1 and 4. 2 is going to affect that 4 tremendously. So it just gets to hang on and just stay the same. It doesn't go anywhere. And so this is how many grams of sodium bicarbonate were in that tablet. And that's great, but I need to know how much percentage that is to the entire tablet. Did we find out the mass of the entire tablet? The answer is yes, we did. We did find out the mass of the tablet. So I want you to look right up here for me. And we can see that we did indeed find the mass of the tablet right here, and it was 3.26 grams. So we are going to say, well, how much is 1.4 of 3.26? So we're going to find the percentage for that, okay? So we are going to go to do some math. So we said 3.26 grams was the mass of the tablet, of the whole tablet. Okay. And whenever we're trying to figure out what like somebody's score is on a test or find the percentage out of 100%, right? We're going to put the total amount over that we have over the entire amount. So how many ever you got right over the whole thing, the whole possible value. And in this case, we've got 1.4 grams of sodium bicarbonate out of the entire tablet. We're saying it was 1.4 grams out of the 3.26. Another way of seeing this, so that maybe you're more familiar with it, is writing it vertically. I do not mind whichever way you do it. Okay, you can do it and write it horizontally this way, or you can write it vertically this way. It does not matter to me. But what we end up with is we end up with a final number right here. Now, because we are doing division, we have to follow the rules of how many significant figures we get to keep, okay? So we're going to divide the 1.4 by 3.26, and the final answer we're going to get is 0.4294, blah, 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 blah. Okay, but we already know we're going to be limited to 2 sig figs, which are going to be these 2 here. This is going to affect the 2 tremendously, which means my final answer will actually be 40.43. But I'm not done. This is a decimal point. Technically, I'm reading 43 hundredths, right? So I'm going to go ahead and multiply this times 100 because I want to see what my percentage is. And if I multiply that times 100, I simply get 43%. Again, keeping my 2 sig figs, I get to keep the 43. And so that's actually the total amount of how much we have in that tablet is 43% of that tablet was sodium bicarbonate. And that is pretty much it. And if you have any questions, just go ahead and give me an email or shoot me a text, and I can walk you through that again if you need me to. So you will need to have all of these calculations as well as what the process and the procedure was that we did today. Have a great one.